everybody, in today's video let us go for some fundamental things related to the matrices, and these are also the practice bits related to the matrices. Okay, so first I am writing a matrix 2, 1, 3, some 3, 4, 8 in such a way. This we call it as rows and this we call it as columns. Okay, how many rows are there? 1, 2. And how many columns are there? 1, 2, 3. So this we call it as 2 by 3 matrix. In such a way, some 2, 1, 4, 3 is there. How many rows are there? 2. How many columns are there? 2. So we call it as 2 by 2 matrix. Also we can call them as square matrix. Also we can call them as square matrix. Now this 2, 1 we call it as row matrix, or if it is written in such a way 2, 1 we call it as column matrix. Okay, now if the elements all are 0 in a matrix, then we call it as null matrix, right? If matrix is in such a way that it is 1, 0, 0, 0, 1, 0, 0, 0, 1 in such a way. Now see, these diagonal elements are unity. If diagonal elements are unity and all other elements are 0, then we call it as unit matrix. We call it as unit matrix. Now, if the diagonal elements are non-zero, such as I am taking an example in such a way, all other are 0 and diagonal elements are non-zeros, then we call it as diagonal matrix. We call it as diagonal matrix. Now let us see some upper triangular matrix. So such as, now I will write here the elements will be non-zero in upward side, and as we go in lower side, slowly in such a way I am writing some example, they become zeros. Then we call upper triangular matrix. Now in other way we are also having lower triangular matrix, such as for example 4, 0, 0, 0, 4, 2, 0, 0, 4, 2, 3, 0, 1, 2, 4, 5 in such a way. Then we call it as lower triangular matrix, right? We call them as, here as we are going down, 0 elements are not there, all non-zero elements we are finding. We call it as lower triangular matrix. Now next, now transpose matrix. Transpose matrix, we write it as AT, T for transpose. We call it as transpose matrix. Now here columns are changed into rows and rows are changed into columns, vice versa. So I am taking a matrix such as 1, 2, 3, 4, 5, 6, 7, 8, 4, 2, 3, 1, 3, 4, 2, 1 in such a way, 4 by 4 matrix I took. Now transpose means this row I will write as column 1, 2, 3, 4. Again this row 5, 6, 7, 8. Again this row 4, 2, 3, 1. Again this row 3, 4, 2, 1. So in such a way rows are changed into columns or columns are changed into rows. That we call it as transpose matrix. Next, conjugate matrix. Conjugate matrix we denote with A bar symbol. Now, in conjugate matrix I am taking one example A, 2 plus 3i, 4 minus 7i, 8 minus I, 4 plus some, let us think 7i, here let us keep some 6. In such a way I took one matrix A. Okay. Now here I is a complex term. So now how we will write the conjugate means, simply if plus I is there you place minus I, such as 2 minus 3i. So if minus I is there you place plus I, 4 plus 7i, and this real numbers you just write as this 8. Here minus I plus I, plus I minus I, 4 minus 7, and 6 as it is you have to write. We must not change these numbers. But wherever we are getting the complex number I, if it is plus I, write as minus I. If it is minus I, write as plus I. Now next, transposed conjugate matrix. Transposed conjugate matrix. Now the same example I am taking. So first A we are having 2 plus 3i, 4 minus 7i, 8 minus I, 4 plus 7i, 6. First what we have to do, we have to write the conjugate matrix. 2 minus 3i, 4 plus 7i, 8 plus I, 4 minus 7i, 6. Then I have to write the transpose of these conjugate matrix. So transpose means changing the rows into columns. Okay. Now this row I will write as column 2 minus 3i, 4 plus 7i, 8. Next this one I, 4 minus 7i, 6. In such a way, first we have to find the conjugate, then we have to write the transpose of it. This we call it as transposed conjugate matrix. Okay. Now next, the next one, symmetric matrix. Okay. Symmetric matrix. Now here we will write it as Aij equal to Abi for all I comma j's. I am taking one example, 1 I minus 2i, I minus 2, 4 minus 2i, 4, 3. I took this example. Okay. So now let us forget about this diagonal. So now, or let us consider the elements above diagonal and below diagonal. Now see, here what you are having, I minus 2i, 4. I minus 2i, 4. Means these elements, we can say the mirror image of these elements, no? So such matrices we call symmetric matrices. These elements are mirror image of these elements. See, I minus 2i, 4 are mirror image of these elements. We call them as symmetric matrix. Okay. Now next, let us go for Skew symmetric matrix. Skew symmetric matrix. So here we will write Aij equal to minus Abi, or A transpose is equal to minus A we have to get. Then we call it as symmetric matrix. Now here also, in a symmetric matrix also, we can write A is equal to A transpose. Let us take one example now. Let us see. A equal to some 2, 5, minus 1, 5, 4, 2, minus 1, 2, 4 I took. I am writing the A transpose of this row as column 2, 5, minus 1. Again 5, 4, 2. Lastly minus 1, 2, 4. Now see, this is A, no? This is A transpose. 2, 2. 5, 5. Minus 1, minus 1. 5 minus 1. 4, 2. 2, 4. So A transpose is equal to A, we can say, no? So this also, with this we call it as symmetric matrix. Now in a skew symmetric matrix, A transpose must be equal to minus A. Let us take one example now. A equal to 0, 3, 4, minus 3, 0, 7, minus 4, minus 7, 0. Let us see. First let us write the A transpose of this. 0, 3, 4, minus 3, 0, 7. What we did? Rows as columns. Minus 4, minus 7, 0. Now I will take minus common. What I will get? 0, 3, 4, minus 3, 0, minus 7. Alright. Next. Minus 4. So this is plus 7. I am sorry. Minus 4, minus 7, 0. I took minus common. Now see A, compare this. 0, minus 3, minus 4. 0, minus 3, minus 4. 3, 0, minus 7. 3, 0, minus 7. 4, 7, 0. 4, 7, 0. Means this is nothing but A. So A transpose is equal to A. Now let us take some other example. Okay, I am taking some other example also. Now here he is asking the skew symmetric matrix. In two methods we can know. So such as now next I am taking an example of 0, 3i minus 4 minus 3i, sorry, not minus, plus only 3i, 0, 8, 4, minus 8, 0. Now here complex terms are there. Here complex terms we will not change. We will write as it is. Alright. Now let us see. First let it be A. So A transpose 0, 3i minus 4. Again 3i, 0, 8, 4, minus 8, 0. Minus I am taking common. So what we will get? 0, 3i minus 4. 3i, 0, plus 8, plus 4, minus 8, 0. Minus. Now compare A and this. 0, 3i, 4, 0, 3i, 4. 3i, 0, minus 8, 3i, 0, minus 8. Minus 4, 8, 0, minus 4, 8, 0. Means this is nothing but A. So A transpose. If we get the complex numbers, then don't change it. Write as it is. Okay. Don't add any negative signs or minus sign. How it is there, you just write down. The other example for skew symmetric matrix. Okay. Now next, let us move for Hermitian matrix. So actually in practice how we will ask in the exam is, he will give A, B, C, D options and he will ask which is Hermitian matrix, which is Q-symmetric matrix. In such a way he will ask. So if you remember the formulas, then easily you can identify which is the Hermitian matrix, Q-Hermitian matrix, symmetric matrix, Q-symmetric matrix, transpose matrix, in such a way. Right? Now, Hermitian matrix. Okay. The formula for Hermitian matrix is A conjugate transpose is equal to A. Means first we have to find the conjugate value, then the transpose of that, and that value must be equal to A. Okay. Now here I am taking one example. A as 0, I minus I 0. First what I have to do? Conjugate. Conjugate means what I said. So if plus I is there, you keep minus I. If minus I is there, you keep plus I. I wrote conjugate. After that, let us find the transpose. Transpose means row as column. I 0. Right? Now see, compare the A and this value 0 minus I, 0 minus I 0, I 0 means this is nothing but A. So A conjugate transpose must be equal to A, then we call it as Hermitian matrix. Now let us see Q Hermitian matrix. Okay. So here the formula is A conjugate transpose equal to minus A. Now let us take one example now. A equal to 0, I 0, I took the example. First I have to write the conjugate value 0 minus I 0. Then I have to write the transpose of it 0 minus I 0. I am taking minus as common. What I will get? 0 I 0. Now compare this with A. 0 I 0 I 0 I 0 means A conjugate of transpose is equal to minus A. This is skew Hermitian matrix. Right? Now next, some other bits such as, so the condition for matrix A to be proper orthogonal matrix, the condition for matrix A to be proper orthogonal matrix, that is magnitude A equal to plus 1. This is the condition. Now if A satisfies the condition of some A transpose is equal to 1, then A is said to be unitary matrix. Okay. So now if we divide adjacent A, okay, if we divide adjacent A by det A, here det A equal to 1, det A equal to 1, this is the condition for proper orthogonal matrix. Adjacent A by det A, we will get A inverse. Right? Now next, let us see if some A and B are matrices of same order such that AB equal to A, BA equal to B. Then A and B we call it as idempotent matrix. Idempotent matrix. Now, if A is non-singular matrix of order 5 by 5, then rank of A will be 5. Ranks in my next video I will explain. Now, next, for a system of m linear equations are there, for example, you think in some n unknowns, in some n unknown values m linear equations are there. Then if m equal to n, Cramer's rule is applicable. In my further video I will explain this all in details. Cramer's rule is applicable. And coefficient matrix is non-singular. Okay. So these are the some of the fundamentals regarding the matrices. If you think that my video is useful for your entrance exam preparation, like it, subscribe it, share it and recommend for all that aspirants who are preparing for the SET, NET and the JL exams. Thank you.